Louis Slotin, from Wikipedia, the free encyclopedia. Louis Alexander Slotin, December 1st, 1910 to May 30th, 1946, was a Canadian physicist and chemist who took part in the Manhattan Project. He was born and raised in the north end of Winnipeg, Manitoba. After earning both his Bachelor of Science and Master of Science degrees from the University of Manitoba, Slotin attended King's College, London, where he obtained his doctorate in physical chemistry in 1936. Afterwards, he joined the University of Chicago as a research associate to help design a cyclotron. In 1942, he was invited to participate in the Manhattan Project. As part of the Manhattan Project, Slotin performed experiments with uranium and plutonium cores to determine their critical mass values. After World War II, Slotin continued his research at Los Alamos National Laboratory. On May 21, 1946, Slotin accidentally began a fission reaction which released a burst of hard radiation. Slotin was rushed to the hospital and died 9 days later on May 30th, the victim of the second criticality accident in history. Slotin was hailed as a hero by the United States government for reacting quickly enough to prevent the deaths of his colleagues. However, some physicists argue that this was a preventable accident. The accident and its aftermath have been dramatized in fiction. Contents. Section 1, Early Life. 1.1, King's College. 1.2, University of Chicago. Section 2, Los Alamos. 2.1, The Criticality Accident. Section 3, Legacy. Section 4, References. Section 5, External links. Section 1, Early Life. Slotin was the first of 3 children born to Israel and Sonia Slotin, Yiddish-speaking refugees who had fled the pogroms of Russia to Winnipeg, Manitoba. He grew up in the North End neighborhood of Winnipeg, an area with a large concentration of Eastern European immigrants. From his early days at McRae Elementary School through his teenage years at St. John's Technical High School, Slotin was academically exceptional. His younger brother, Sam, later remarked that his brother had, quote, an extreme intensity that enabled him to study long hours, end quote. At the age of 16, Slotin entered the University of Manitoba to pursue a degree in science. During his undergraduate years, he received a university gold medal in both physics and chemistry. Slotin received a Bachelor of Science degree in geology from the university in 1932 and a Master of Science degree in 1933. With the assistance of one of his mentors, he obtained a fellowship to study at King's College London under the supervision of Arthur John Almond, the chair of the chemistry of the department, who specialized in the field of applied electrochemistry and photochemistry. Section 1.1, King's College. While at King's College, Slotin distinguished himself as an amateur boxer by winning the college's amateur bantamweight boxing championship. Later, he gave the impression that he had fought for the Spanish Republic and flown experimental fighter jets with the Royal Air Force. Author Robert Junk, Jungk, recounts in his book Brighter Than a Thousand Suns, A Personal History of the Atomic Scientists, the first published account of the Manhattan Project, that Slotin, quote, had volunteered for service in the Spanish Civil War, more for the sake of the thrill of it than on political grounds, end quote. During an interview years later, Sam stated that his brother had gone, quote, on a walking tour in Spain, end quote, and he, quote, did not take part in the war, end quote, as previously thought. Slotin received a doctorate in physical chemistry from the university in 1936. He won a prize for his thesis entitled, quote, An Investigation into the Intermediate Formation of Unstable Molecules During Some Chemical Reactions, end quote. Afterwards, he spent 6 months working as a special investigator for Dublin's Great Southern Railways, testing the drum nickel-zinc rechargeable batteries used on the Dublin-Bray line. Section 1.2, University of Chicago. In 1937, after unsuccessfully applying for a job with Canada's National Research Council, the University of Chicago accepted him as a research associate. There, Slotin gained his first experience with nuclear chemistry, helping to build the first cyclotron in the Midwestern United States. The job paid poorly, and Slotin's father had to support him for 2 years. From 1939 to 1940, Slotin collaborated with Earl Evans, the head of the university's biochemistry department, to produce radiocarbon, carbon-14 and carbon-11, from the cyclotron. While working together, the two men also used carbon-11 to demonstrate that animal cells had the capacity to use carbon dioxide for carbohydrate synthesis through carbon fixation. Slotin may have been present at the startup of Enrico Fermi's Chicago Pile 1, the first nuclear reactor, on December 2, 1942. However, the accounts of the event do not agree on this point. During this time, Slotin also contributed to a number of papers in the field of radiobiology. His expertise on the subject garnered the attention of the United States government, and as a result he was invited to join the Manhattan Project, the United States' effort to develop a nuclear bomb. Slotin worked on the production of plutonium under future Nobel laureate Eugene Wigner at the university and later at the Oak Ridge National Laboratory in Oak Ridge, Tennessee. He moved to the Los Alamos National Laboratory in New Mexico in December 1944 to work in the bomb physics group of Robert Bacher, B-A-C-H-E-R. Section 2. Los Alamos. At Los Alamos, Slotin's duties consisted of dangerous criticality testing, first with uranium in Otto Robert Frisch's experiments, and later with plutonium cores. Criticality testing involved bringing masses of fissile materials to near critical levels in order to establish their critical mass values. Scientists referred to this flirting with the possibility of a nuclear chain reaction as tickling the dragon's tail, after a remark by physicist Richard Feynman, who compared the experiments to, quote, tickling the tail of a sleeping dragon, end quote. On July 16, 1945, Slotin assembled the core for Trinity, the first detonated atomic bomb. He became known as the, quote, Chief Armorer of the United States, end quote, for his expertise in assembling nuclear weapons. After the war, Slotin expressed growing disdain for his personal involvement in the project. He remarked, quote, I have become involved in the Navy tests, much to my disgust, end quote. Unfortunately for Slotin, his participation at Los Alamos was still required because, as he said, quote, I am one of the few people left here who are experienced bomb-putter-togetherers, end quote. He looked forward to resuming his research into biophysics and radiobiology at the University of Chicago and was training a replacement, Alvin C. Graves, to take over his work once he resumed his peacetime job. On August 21, 1945, Harry K. Daghlian, D-A-G-H-L-I-A-N, one of Slotin's close colleagues and a laboratory assistant, was performing a critical mass experiment when he accidentally dropped a small tungsten carbide brick onto a 6.2 kilogram delta-phase plutonium bomb core. The 24-year-old Daghlian was irradiated with 510 rems, 5.1 sieverts, of neutron radiation. As the young man spent the next 21 days in the hospital, slowly succumbing to radiation sickness, Slotin spent many hours with him. Section 2.1. The Criticality Accident. On May 21, 1946, Slotin and 7 other colleagues performed an experiment that involved the creation of one of the first steps of a fission reaction by placing 2 half-spheres of beryllium, a neutron reflector, around a plutonium core. The experiment used the same 6.2 kilogram, 13.7 pound, plutonium core that had irradiated Daghlian. Slotin grasped the upper beryllium hemisphere with his left hand through a thumb hole at the top, while he maintained the separation of the half-spheres, using the blade of a screwdriver with his right hand, having removed the shims normally used. Using a screwdriver was not a normal part of the experimental protocol. At 3:20 p.m., the screwdriver slipped and the upper beryllium hemisphere fell, causing a, quote, prompt critical, end quote, reaction and a burst of hard radiation, At the time, the scientist in the room observed the blue glow of air ionization and felt a, quote, heat wave, end quote. In addition, Slotin experienced a sour taste in his mouth and an intense burning sensation in his left hand. Slotin instinctively jerked his left hand upward, lifting the upper beryllium hemisphere and dropping it to the floor. He exposed himself to a lethal dose, around 2100 rems, or 21 sieverts, of neutron and gamma radiation. Slotin's radiation dose was identical to the amount he would have received had he been 4,800 feet, 1,463 meters, away from the detonation of an atomic bomb. As soon as Slotin left the building, he vomited, a common reaction from exposure to extremely intense ionizing radiation. Slotin's colleagues rushed him to the hospital, but irreversible damage had already been done. His parents were informed of their son's inevitable death, and a number of volunteers donated blood for transfusions, but the efforts proved futile. The accident ended all hands-on assembly work at Los Alamos. At first, the incident was classified and not made known even within the laboratory. Robert Oppenheimer and other colleagues later reported severe emotional distress at having to carry on with normal work and social activities while they secretly knew that their colleague lay dying. Louis Slotin died 9 days later on May 30th in the presence of his parents. He was buried in Winnipeg on June 2, 1946. 3 of the 7 survivors of the accident died years later from causes possibly related to radiation exposure. The core, which later was termed the Demon Core due to the accidents it had led to, was subject to a number of experiments shortly after the war and was used in the Able, ABLE, detonation during the Crossroads series of nuclear weapon testing. Slotin's experiment was set to be the last conducted before the core's detonation and was intended to be the final demonstration of its ability to go critical. Section 3. Legacy. On June 14, 1946, the associate editor of the Los Alamos Times, Thomas P. Ashlock, penned a poem entitled Slotin, a Tribute. May God receive you, great-souled scientist. While you were with us, even strangers knew the breadth and lofty stature of your mind. 'Twas only in the crucible of death we saw at last your noble heart revealed. The official story released at the time was that Slotin, by quickly removing the upper hemisphere, was a hero for ending the critical reaction and protecting 7 other observers in the room. Quote, Dr. Slotin's quick reaction at the immediate risk of his own life prevented a more serious development of the experiment, which would certainly have resulted in the death of the 7 men working with him, as well as serious injury to others in the general vicinity. End quote. However, Robert B. Brody, a top physicist who worked on the project, argued that the accident was avoidable and that Slotin was not using proper procedures, endangering the others in the lab along with himself. In 1948, Slotin's colleagues at Los Alamos and the University of Chicago initiated the Louis A. Slotin Memorial Fund for lectures on physics given by distinguished scientists such as Robert Oppenheimer and Nobel laureates Luis Walter Alvarez and Hans Bethe. The Memorial Fund lasted until 1962. The incident was recounted in Dexter Masters' 1955 novel The Accident, a fictional account of the last few days of the life of a nuclear scientist suffering from radiation poisoning. The accident and its aftermath were dramatized in the 1989 motion picture Fat Man and Little Boy, which starred John Cusack as Michael Merriman, a fictional character based on Slotin. Author Paul Mullen wrote the play Louis Slotin Sonata, a dramatic recreation of the events that unfolded on May 21, 1946. In 2002, an asteroid discovered in 1995 was named 12423 Slotin in his honor. End of article text. This reading corresponds to the text of the article as it appeared at 3:51 a.m. on January 21, 2008.